So, good day. Today's topic is from the machine learning concept, concept learning, find S algorithm. So, what is find S algorithm? The find S algorithm is a foundational concept algorithm in machine learning that finds the most specific hypothesis consistent with all the positive training examples. It works by starting with a maximally specific hypothesis and generalizing it only when necessary to cover observed positive examples while completely ignoring negative examples. Key concepts are like hypothesis, a proposed rule that explains the target concept, most specific hypothesis, and initial hypothesis where no value is acceptable for any attribute, often represented as pi, where pi means null or empty. Most general hypothesis where any value is acceptable for all attributes, represented as question marks, where question mark means they don't care. So that is a attribute where it doesn't follow any kind of rules or procedure or anything. The concept learning, like the task of learning to identify a specific category or concept from a set of labeled examples. Algorithm steps like this, the following are the algorithm steps for the finders algorithm. So, put it in a straightforward iterative process. Initialize the hypothesis H to the most specific hypothesis possible, example 5, and iterate through examples for each training example. If an example is negative, ignore the example and do not update the hypothesis H. If the example is positive, for each attribute in the example, compare it with the corresponding attribute in H. If the attributes match, do nothing. If the attributes differ, replace the attribute in H with the next moral general, sorry, with the next more general constraint that is satisfied by the example, which is always the question mark, the don't care symbol in for to this specific scenario in the standard finders algorithm. Output is after processing all the examples, the final hypothesis H is the most specific one that covers all positive instances. And limitations of Finders algorithm is, despite its simplicity and education value, the Finders algorithm has several significant limitations. Ignores negative examples. It cannot use negative data to refine the hypothesis or eliminate inconsistent ones. Assumes noise-free data. It is highly sensitive to noise or errors in the training data because it has no mechanism to handle contradictions. Single hypothesis, it only produces one final hypothesis, even if multiple hypotheses could fit the positive examples equally well. No consistency check. It offers no need It offers no way to determine if the final hypothesis is consistent with the entire data, particularly with the negative examples it ignores. These limitations led to the development of more advanced algorithms like candidate elimination algorithm, which addresses these issues by using both positive and negative examples to define a version space of the possible hypothesis, which will be see it later. The find-S algorithm is fundamental concept learning algorithm machine learning that finds the most specific hypothesis consistent with all the positive training examples. It follows a specific to general approach, starting with the maximally specific hypothesis and generalizing it only when a positive example is covered or not covered. Hypothesis representation, it is represented by five. Hypothesis in the defined as algorithm are typically represented as a conjunction of constraints on the attributes. Specific symbol are used to denote the level of generality for each attribute. 5 or 0 null. represents the most specific constraint, indicating that no values is acceptable initially. This is used for the initial hypothesis. Specific value, a defined value, example warm, sunny, means only that exact value is acceptable for the attribute. Question mark represents the most general constraints, a don't care or wildcard symbol, meaning any value is acceptable for that attribute. The most specific possible hypothesis is a vector of five values. For example, 5, comma 5, comma 5, comma 5. The most general possible hypothesis is a vector of question mark for question mark value. For example, question mark, comma question mark, question mark. The find-S algorithm steps the algorithm operates iteratively on the training data, modifying the hypothesis only in the response to the positive example. Initialize the hypothesis heights to the most specific possible representation, which is a vector of null and constraints of all attributes. Example 5, 5, 5, 5, so on. For each training example, if the example is negative, ignore the example and do not change the hypothesis. And if the example is positive for each attribute in the example, if the attribute value of the current hypothesis is 5, replace it with the specific attribute value from the positive example. If the attribute value of the hypothesis does not match the value of the positive example, replace it with the value wildcard symbol question mark, thereby generalizing the constraint. If the attribute value match, do nothing. Output the final hypothesis after processing all training examples. This hypothesis is the most specific one that covers all observed positive examples. Again, limitations ignores negative value. The algorithm does not use negative examples, which can lead to inconsistencies if the training data is noisy or contradictory. Finds only one hypothesis, it guarantees finding the most specific consistent hypothesis, but overvalue more general hypothesis might exist that it doesn't find. Assume noise-free data. It works best with the simple noise-free data sets. The FindS algorithm serves as a useful educational tool for understanding core machine algorithm concepts, but it is not typically used in complex or real-world applications due to these limitations. It is a foundation for more advanced algorithms like candidate elimination algorithm, which addresses some of its drawbacks. So here in this again, uh, find this algorithm. I'll be showing the code at the end of this video. Please have a look into it. This is the code, and I will execute and show the output like this. So where these finders algorithms are used, the applications or concept learning used to demonstrate how algorithms search for hypotheses in machine learning. Generalization process shows the transition from specific to general hypothesis. Foundation role serves as a basis for advanced methods like candidate elimination and version-based learning. Small datasets works best on limited, noise-free datasets with only positive examples. Educational use commonly applied in classrooms to explain supervised learning. Advantages simplicity, very easy to understand and implement. Efficiency only considered as a positive examples, reducing computations. Transparency clearly shows how hypotheses evolve with new data. Specificity guarantee always finds the most specific hypothesis consistent with positives. Beginner friendly, a perfect for learning concept generalization basics. Disadvantages ignores negatives, does not consider negative examples in learning. Noise sensitivity assumes data is and noisy, perfect and noise free. Inconsistency problem cannot handle contradictions in the data set. Single hypothesis produces only one hypothesis, even if others fit. Limited use are not practical for complex or real world data set. That's it for today. Thank you. So here, this is a sample code in the finest. So here we are importing the libraries, and here we are defining the data frame with colors, textures, and labels. And here the hypothesis is calculated using the phi into data dot shape of minus 1. So this is the formula here using the hypothesis for this problem. And here we process all the given data, and then we are trying to find the hypothesis. So the final hypothesis value for this particular problem is for this particular data field is like in comma the question mark which is don't care means it accepts all kinds of attributes. That's it from the final answer.